Greetings, welcome to my channel Geometry Puzzles. In this video we are going to discuss a very insightful problem in geometry. The problem statement is as follows. AB and AC are tangents to circle O shown in the figure. AO cuts the circle at D, D being away from A. Point C and D are then connected. A perpendicular is drawn from B onto CD to meet at X. Y is the midpoint of BX. dy extended cuts the circle at Z. The task is to show that the angle AZC is 90 degrees. So let us try to solve this problem in this video. And if you wish to have a Word file for this problem statement, then you can check the link in the description to this video. I have posted the Word document which is printable. So without any further ado, let us start the solution to this problem. We will make a few constructions on this diagram first, and these constructions will benefit us to show what is asked. So let me pull up the diagram which consists of the constructions. I have a diagram here already, so let me, alright, it is hiding the higher problem statement, so let me write the problem statement here. Alright, so on the extreme left we have the diagram according to the question, and at the center we have a diagram with constructions that we have made. Basically we have connected a few points. The constructions are shown in blue. So we have points BC connected, and BC is allowed to intersect AO at E, and then we have BZ, ZE and EY shown by red segments, thin red segments, to just get a visual representation of this quadrilateral BZEY. Alright, so let us begin with the proof. First we notice that E is the midpoint of BC. So let me write it over here. Perhaps I can take this diagram downstairs here and write all my arguments on this space over here. Alright, so first we notice that E is the midpoint of BC. E is the midpoint of BC. Therefore BE is equal to EC. And we argue E is the midpoint of BC by symmetry. This is true by symmetry. So I will not prove that E is the midpoint of BC. It is quite obvious from symmetry that E is the midpoint of BC. Further, Y is the midpoint of BX, which is given in the problem statement. So Y is the midpoint. So I write BY is equal to YX. Now since BE is equal to EY and BY is equal to YX, we have YE parallel to CX. This comes from a basic property of a triangle. If you have two midpoints of any two sides, the segment connecting these two midpoints is parallel to the third side. So this is a property in triangle, and this is the property, exactly this property we are using over here to justify that YE is parallel to CX. Now since BX is perpendicular to CD, which is given, so BX is perpendicular to CD, this is given in the problem statement. Should I, let me see if I can keep the problem statement at a certain corner, if it is possible. Yes, alright, fair enough. So this is a problem statement over here. Alright, so BX is perpendicular to CD as per the problem statement. Therefore BY is 90 degrees because CX is parallel to YE. So if this angle is 90 degrees over here, then this angle is also 90 degrees because YE is parallel to CX. So we write angle BYE is equal to 90 degrees. Now we will show that quadrilateral BZEY is cyclic. Quadrilateral, let me write here. Quadrilateral BZEY is cyclic. This is what we are going to prove. In order to prove quadrilateral BZEY is cyclic, we are going to use a property in circles, which is as follows. Suppose you have a segment. If you have a segment, any segment, and you consider any point, suppose this is a segment AB, you consider any point P. Now this point P will make a certain angle with segment AB. Now you consider any other point Q. This point as well will subtend or make a certain angle with segment AB. Now these two angles will be equal only when all the 4 points AB, PQ lie on the same circle. Otherwise they will not be equal. So as a corollary, we have, if these two angles are equal, then all the 4 points lie on a circle. So the theorem goes two ways. So this is the property which we are going to use. So if I show that these two angles are equal, then quadrilateral ABQP is a cyclic in this diagram. So this is the property which we are going to use. So let us go upstairs. Over here. Now notice angle BZY is equal to angle BZD. Basically they are the same angle, which is further equal to angle BCD, because they subtend the same arc. So angle BZD and angle BCD, they subtend this arc over here. So as they subtend same arc, the angles are equal. Further, angle BCD is equal to angle BEY. This is because YE is parallel to CX. So if BCD, if this is a certain angle, then BEY, this angle is equal to this angle over here because YE is parallel to CX. So from this long equation, we conclude that angle BZY is equal to angle BEY. So this angle over here, BZY, this angle over here, BZY and BEY are equal. So from the property I just discussed, quadrilateral BZEY is cyclic. So we just showed that quadrilateral BZEY is cyclic. Now, where do we go from here? We know that angle BYE is 90 degrees. So let me just, we know that angle BYE is 90 degrees. We had proved this before. Therefore, the opposite angle BZE is also 90 degrees in quadrilateral BZEY. Therefore, the opposite angle BZE is also 90 degrees. And let me name this equation. Let me call this equation A. So BZE is equal to 90 degrees because, by the way, let me just erase these two. Alright, so BYE, this is 90 degrees. So BZE is also 90 degrees because they are opposite angles of a cyclic quadrilateral, and opposite angles sum up, they are supplementary. So opposite angles make up 180 degrees in total. Now, our task is to show angle AZC is 90 degrees. This is our task. Showing angle AZC as 90 degrees is same as showing quadrilateral AZEC is cyclic. So these are two sides of the same coin. So if I show that quadrilateral AZEC is cyclic, then it will follow that angle AZC is 90 degrees. This is because we know angle AEC is 90 degrees. AEC, this angle over here is 90 degrees. Did I mention this anywhere before? Alright, while I mentioned this BE is equal to EC, I should have mentioned one more fact which comes from symmetry, the fact that BC is perpendicular to AE. BC is perpendicular to AE, and this comes from symmetry. I mean, it is very easy to show that BE is equal to EC, and also BC is perpendicular to AE. So it is very easy to show, so I am not going to discuss the proof of that. So BC is perpendicular to AE, and for that reason AEC, angle AEC is 90 degrees. So if I show that quadrilateral AZEC is cyclic, then it will follow that this angle over here is equal to this angle from the property I just discussed. And the same property, by the way, we used to prove this quadrilateral BZEY is cyclic. So our task now reduces to show that quadrilateral AZEC is cyclic. So let us quickly prove that quadrilateral AZEC is cyclic. Let me pull the diagram again because we are running out of space. Okay, so this is our diagram. and we may borrow a few arguments from this part. So all right, let me give the heading over here: proving quadrilateral A Z E C is cyclic. What we are going to do is we will show angle ACZ is equal to angle AEZ. Angle ACZ is equal to angle AEZ. So this is what I will establish. Let us see the proof of this as well. Consider the following. Angle ACZ. This angle is equal to angle CBZ. This comes from a certain property in circles. So for example, if you have a circle over here, if you have a circle like this and there is a tangent, for example, like this, then what you do is you consider a certain point on the circle, any point. Suppose this is one point A. Then you consider any other point, further any other point B, and you connect the following segments. You connect this segment over here and you connect this segment over here, and you connect this segment as well. Now the property is this angle is going to be equal to this angle. So if this angle is alpha, this angle is also alpha. This is true for any circle. So no matter where this point B is, if the point B is over here, still you have the same property. This is also alpha, and this angle over here is also alpha. So this is a property, and this property, based on this property, we have angle ACZ equal to angle CBZ. Now further, this angle is equal to EBZ, angle EBZ. This is quite apparent from the diagram because it is just an extension of one segment. So you have angle CBC is equal to angle EBC. Further, this is equal to angle EBC is equal to 90 degrees minus angle ZEB. Why is this true? It is true because of the following argument. So because triangle BZE is a right angle triangle, right angle triangle. Why is it a right angle triangle? Because of equation A. We had proved previously that according to equation A over here, we had proved that angle BZE is 90 degrees. So because angle BZE is 90 degrees, triangle BZE is a right angle triangle. So therefore we have angle ZBE in triangle BZE plus 90 degrees, the right angle of the triangle, plus angle BEZ as 180 degrees. So what we have here, we have angle EBZ as 90 degrees minus angle BEZ, and that is exactly what I have written over here. So that is the justification of the last part of the equation. Angle EBZ is equal to 90 minus angle ZEB. So what do we have in the end? We have that angle ACZ is equal to angle AEZ. I'm sorry, one more thing we have to show here is that this is further equal to angle ZEA. This is equal to ZEA. And why is that true? It is true for the following reason. Notice as angle AEB is 90 degrees, let me write here angle AEB is 90 degrees. As this is true, we have angle AEZ plus angle ZEB is equal to 90 degrees. So basically they are adjacent angles. Therefore angle AEZ is equal to 90 degrees minus angle ZEB. And this is exactly what we have here. So what do we have in the end? Let me make space. Let me create space over here. So what do we have in essence? We have angle ACZ is equal to angle ZEA. This is what we have. And this is exactly what we intended to prove. So this one over here. So this is proved. And because these two angles are equal, we can write safely that AZEC is cyclic. And because quadrilateral AZEC is cyclic, as we argued earlier, angle AZC is 90 degrees because angle AEC is 90 degrees. So in this manner we show what is asked. I thank you for watching.